and not very different from direct variation. The only difference is that we're solving problems where our graph does not go through 0, 0. Okay, so it does not go through 0, 0. And as you can see, my student Charlie, my only student I have as I write this, as I talk, is still sleeping through my lesson, which is a little discouraging. Okay, so just to compare, last lesson was about direct variation, partial variation. If we were going to look at the two graphs, this is what they would look like, right? Direct variation goes through 0, 0. That's the only thing you really need to notice about it. Partial variation will intersect the y-axis. Remember that the up-down axis or the vertical axis is always, we call it the y, and it contains the dependent variable, and the x-axis is always the independent variable, and it's always horizontal. Okay? Right? So that's direct and partial, and a couple just as far as writing down the differences between them, that's it. Excuse me. In this one, the line must go through 0, 0. We also call 0, 0 is the origin, by the way. The point 0, 0 equals origin. Okay. In both cases, we only talk about what we call linear relations or straight lines. Okay, if there's a curve, which we don't do in this class, if there's a curve, you're supposed to be in grade 10. They made a mistake and I gave you a grade 10 question. Okay, everything's a straight line. All right, so we're going to use a very specific example to compare fixed and direct variation and to look at the idea, the concept of partial variation using fixed and variable costs. I think I said that wrong, but the point is that we're talking about fixed and variable costs, which is just one particular application. It's not always, but we're saying fixed cost is a flat rate that's paid no matter what, and variable is a cost that changes depending on usage, and you'll see the example on the next page. Okay? Well, if you're not sure what I mean by that, you'll see it now. Ferd has a cell phone plan, okay? And he pays $12 a month no matter what, okay? And then he pays 20 cents or $0.2 every minute of talk. So we're supposed to write an equation to model the cost of the phone plan. Well, first of all, let's just let M be the minutes used and let C be the cost. So we just have letters instead of full words. So the cost, the total cost, is going to be the $12 he pays per month no matter what, plus 0.2 times, that's a times in this case, times the minutes of use. Okay? Identify the fixed cost. Well, the fixed cost is the part that's no matter what happens, he has to pay it. So that's the $12. Doesn't matter if he never uses his phone, he still pays 12 bucks. Okay? And the variable cost is the 20 cents per minute of the $0.2, okay? Because it's totally, that's what we call, that's the constant of variation. It's the rate of pay, right? Let's do it per minute. Oh boy. Okay, so that's the fixed and the variable cost. All right, so just some little, this y equals mx plus b, it's like the general form of an equation. You can take a sec to write all this down. It's the general form of any equation for any line. Okay, when we're talking about fixed and variable cost, the variable cost is what we call the M. M is the amount that it that's like the 20 cents in the last example. The fixed cost is the part that happens no matter what. X is what we call the independent variable, and Y is the dependent. And just remember, Y is always dependent, X is always independent. We've said that before. Okay? Okay, big example. Ferd is printing flyers to advertise his lawn cutting business. He must pay a fixed cost of $5. So it tells us the fixed cost, right? And then $1 for each 100 flyers that are made. So it says identify the dependent and independent variables. So there's no time this time, so it's a little bit harder, okay? Independent and dependent. So dependent, I'll just go capital D for dependent, is going to be the total cost for all the variables, okay? For all the flyers, sorry, total cost. So the part that he must pay, okay? Independent is going to be the number of flyers. Let's think this through, okay? The total cost is completely dependent on how many flyers he buys. So it's dependent, number of flyers is independent. Then it says identify fixed and variable cost. Well, fixed is what he pays no matter what. That's going to be, he must pay a fixed given, $5. Doesn't matter how many flyers he makes, he's got to pay $5. Okay? And the variable cost is the $1, $1 per. That's the variable cost. Okay? Determine the equation that will model. So we're going to use the model we used above, where we said the y, which is the dependent variable, so that would be total cost, the dependent variable, equals the variable cost, which is 1 times the independent variable, which is number of flyers, plus the fixed cost. Now if over here we just say let total cost be and number of flyers be F, then our equation would look like this. C equals F plus 5. Really, it's the number of packages of 100. Okay. And I just said F instead of 1 times, because 1 times anything is just that. Okay. So there's my equation. Next it says graph that equation. Well, I just want to remind you again that dependent variable is y, independent variable is x. Okay? So let's look at the next page. Make this smaller so you can see the whole thing. Okay. So you can fill out your grid there, but I should have written it down, but I guess I'm saying if you need more time, but the x value is this is the number of packages of 100. Okay, this is like my F, right? And this is total cost. Okay. So as I graph it then, I might just choose a different color. As I graph it, the first point, no matter what happens, he pays $5. Even if he sells 0 flyers, right? If he sells 0 flyers, it's still going to cost 100. That's my first point. And then after that, right, we just look back. After that, he pays $1 for each 100 flyers. So just remembering that each package of flyers is $1, right? So one package of flyers will be $1 more than that. 2 packages of flyers, I just keep going up by 1. Okay? So I could just draw a line out of that. So it starts, so this is why it's called partial variation. It's not starting at 0, 0, it's starting up here. Okay, and that's my relationship. And in part E, it says describe that graph. Okay, again, if I go too fast, you just pause the tape. But in part E, then I'm going to say it's a straight line. It intersects the y-axis at 0, 5, right? Straight line. Everything we do is a straight line. And the y value increases by 1 as the x value increases by 1, right? So every time, every time we buy another 100, it goes up by $1. Another 100, another 100, another 100, another 100. Okay? All right. Now Ferd's on a diet. And it says that he starts at 175 pounds, okay? Starts at 175, and he loses 5 pounds per week. So his mass goes down, which might be a hint that this graph's going to look different because we're dropping, we're not increasing, okay? Anyway, so it says identify the dependent and independent variable. Well, the dependent variable is going to be his mass. I'm going to go D equals, or D is mass, okay? And that mass is dependent on how long he's on his diet. So therefore, the independent variable is number of weeks. And again, that makes sense because it's time. Independence, always time. Okay? So, and if you're thinking, how do I know what to pick? There's really only 2 things going on here. One is mass and one is weeks. If you look at the question, there's only 2 things that could be. You just have to pick which is which. And the easy thing to remember is that time is going to be the independent. Okay? If there's 2 things listed, then it's really easy. Okay, determine the equation that will model his mass during his diet. So let's say let M be mass. You know what? I'm going to not say M, I'm going to say Y. Because we've said that Y is dependent, right? So let's say Y is mass. I'd like to have the same as kind of the same, but M for mass. But we'll say Y is mass because we know that Y is the dependent variable. And we'll let X be number of weeks. So now we can write our equation in terms of y and x. We're going to say his mass is going to be, well, his fixed max, I'm talking about fixed and variable cost, right? Well, the starting point was 175. Take away, and this time I'm subtracting because he gets lighter every time, right? 5 pounds times the number of weeks. Okay? 175 minus, it's minus because he's losing. This key word. If he's gaining weight, it'd be plus, right? Now graph it. All right, let's look at the next page. I've already got it started. Okay, just a quick thing. So I put weeks on diet on the x-axis, mass on the y, because, you know, we said that already. I put the, you know, when you do the little squiggle lines, I did that because I didn't want to, you know, do one line to get all the way to 140. So the little squiggle just means I'm jumping. I'm jumping from 0 to 140 really quick. And then he starts at 175. Okay, so if we want to graph this, we say, okay, well, he starts, and you'll notice, by the way, I'm jumping up by 5s here. So he starts at 175. So draw a dot to mark your starting point. 1 week later, if he loses 5 pounds a week, 1 week later he'll be 170. Right? 2 weeks later, he'll be 165. 3 weeks later, he'll be 160 because he's losing 5 pounds every single week. So this graph looks different. It's going down instead of up. That's all. We can join the dots, create a nice line out of it. So starting here, going through all those dots. Okay. That should be, you should notice a little arrow down there. If you can't see it, it's supposed to be there. Okay, a little arrow, because it really, well, can't really go forever, but based on the equation, it could go forever. Okay, again, if I went too fast, just pause the tape. But if we want to finish up, because we're not done yet, we need to answer some of these questions. So we did the graph, check. Use the equation to determine his mass 3 weeks into the diet. That's part D. So, excuse me. So his mass, Y, will be 175 minus 5 times 3, which is 160. Of course, you could read that off the graph as well. Use the equation to determine his mass 10 weeks into the diet. Y is 175 minus 5 times 10. Now you start to wonder, this is where I think, this guy was 175, 5 times 10 is 50, right? So it's going to be 125. I think that's pretty light for a dude, unless he's really short or really young. Okay, so then F answers that question. Why is this model not good for long lengths of time? Well, the reason is, you know, in this particular case, right, what if it was 100 weeks, right? I mean, you can only get so thin. So this model only works for a short period of time because from a practical point of view, you're not going to lose 5 pounds a week forever. No one can lose You'll fade away. All right, done.